Okay, welcome back from the break. We are still on theory of logarithm. Remember, there is need for you to subscribe to this YouTube channel and follow us on Facebook. Mathematics Net. Very important. Very, very important. All right, we want to conclude on this particular case, which is case 2. Case 2, where we have many log operator. We have been able to solve about 3 problems. Now we need to solve the fourth one and the fifth one. In this case, this time around, we are going to start looking at problems that involve different bases, when the bases are different. So let's take one of the questions quickly. We have question number 4. If I ask you to simplify 81 is 3 minus log 125 is 5. What am I expected to do? What am I expected to do with this? Oh, let's look at this. Still the case of many log operator, like we have seen here. So we still follow the steps. The steps are still with us. Simplification of terms and expressions involving logarithm. We are still on case 2. So take note of the expressions or expression as the case may be and check if the bases are the same. We have taken note of this. Let's see. We have log 81 is 3 minus log 125 is 5. Oh, the bases are not the same. 3 and 5. Oh. So we cannot actually reduce it to a single what? To a single log. So what do? Are we going to run away? No, we cannot. We are giving you power so that when you see mathematics, you can be able to withstand it. The power we want to give you will help you to overcome all the principalities and powers in mathematics. And no mathematics shall by any means harm you. So we have an answer to what we have on the board because a solution has been provided. We said the only time we apply this step 2a is if the bases are the same. Let's see 2b that we have not touched so far. They say if the bases are not the same, what are we expected to do? We do the following. Simplify each term in the expression separately. Oh, beautiful. Using the method for simplifying terms with one log operator. Oh! They have given us an answer. So we simplify this separately. We can't combine them. Even though the operation here is subtraction, we would have said let's divide this, but it will not work. Why? The bases are not what? The same. So we have a way of handling that. We say simplify each term word separately. So we need to simplify this. Using that method, using the simplification of one log operator. So we treat this as one log operator, treat this as one log operator. If we apply indicial method here, ancestors method, we can still apply indicial method. If we apply ancestors method here, we need to discover the ancestor of 81 and 3. Now remember why we are not reducing it to a single log is because the bases are not the same. So we are using these steps now. Okay. The ancestor of 81 is actually 3, and 3 is an ancestor of itself. The ancestor of 125 is 5, and 5 is an ancestor of itself. So let's write them in terms of their ancestors in index form. So 81 is something as 3 raised to the power 4 is 3 minus 125 is 5 raised to the power 3 is 5 now. Remember 81. 3 divided is 27, 3 divided is 9, 3 divided is 3, 3 divided is 1, 1, 2, 3, 4, 3 raised to the power 4. 125, 125, 5 divided is, will give us 25, 5 divided 25 is 5, 5 divided is 1. So it's 5 that gave birth to 125, that's why 5 is the ancestor of 125. So we clear this. So remember the methods. We need to remove this power using the third law. Emphasis again. Let me repeat it again. Log m raised to the power p base a is something as p log m in base a. So we apply this here. We apply this here and here. That will give me what? 4 log 3 in base 3 minus 3 log 5 in base 5. Okay? Having done that, the fourth law is saying that logarithm of a number to its own base is 1. Logarithm of a number to its own base is 1. So these two, the number and the base are the same. So this reduces to 1. The same thing here. So now 4 times 1 minus 3 times 1. They say once we have simplified it, carry out the operation between them to get your answer. 4 times 1 is 4, minus 3 times 1 is 3. And 4 minus 3 will give me what? 1. Oh, isn't that beautiful? Very beautiful. When the bases are not the same, you simplify them separately. This one, handle it the same way we handle single log terms. The same thing we do on this one. Why are we doing that? We would have combined them if the bases were the same, but the bases here are not what? They are not the same. Okay. We still need to take another example on this before we now give you takeaway questions. Beautiful takeaway question. Today we'll be taking lunch, so the lunch question will be available. We'll just give it to you so that you enjoy your lunch. Today's lunch is going to be fried rice with chicken. Don't mind me. It is mathematical fried rice. Anyway, mathematical fried rice. So let's see if we can pick one more question before we now allow you to have some takeaway question. Beautiful. Let's take this one. Let's take this question. We have log. That should be question number 5 now. We have log 81 in base 3 minus log, that's the first question we saw, log square root of 8 in base 2 plus log 3 in base 9. Log 3 in base 9. Okay? Let's see what we have to do. Let's see what we have to do here. So we have log square root of 8 in base 2 plus log 3 in base 9. The bases are not the same, so we need to solve this separately and solve this separately, and at the end of the day we now carry out the operation between them. Remember how we handle this. We are following these steps since the bases are not the same. If the bases are not the same, simplify each term separately. That's what we want to do. Remember that we said that square root of a number is that number raised to power half. So we have this. We have log 3 base 9. Okay? Let me handle this separately, and I'll also handle this separately. Remember why we are not combining them. The bases are not the same. Even though we have addition, we can't combine them because they have different bases. Okay? Look at this. What's the ancestor of 8? The ancestor is 2 already. I know you have mastered so many ancestors by now. The ancestors that 2 can be, the numbers that 2 can produce, the numbers that 3 can produce, and the numbers that 5 can produce, numbers that 10 can produce. So we have this. So we have log. If we write 8 in terms of its ancestor, it's going to give us 2 raised to power 3. But remember, we have another power here. 8 alone is 2 raised to power 3. We have a power of 1 over 2. This thing in base 2 plus log. The ancestor of 3 and 9 is 3. So we need to write 9 in terms of its ancestor. 3 is already the ancestor of itself. So we keep it that way. 9 is 3 raised to power 2. Okay? We go further. What else should we do? We need to remove this power. This will not help us. So let's simplify the power first. We're going to have log 2 raised to power 3 over 2 base 2. Because this 3 times 1 over 2 will give me that plus log 3 in base 3 raised to power 2. Now we have a method of removing power from the number and power from the base. You remember those logs. Let me put it down again. Log m dash in base a is something as p log m in base a, and log m in base a raised to the power n is something as 1 over n log m base a. So alternative form of writing this is to write it like this when you remove the power from this. So which is what we are going to apply here. While we apply this one on this. So if we do that, we're going to have 3 over 2 log 2 base 2 plus. Now removing this, we write it in this form. It will now be 1 over 2 log 3 base 3. Oh, beautiful. Very beautiful. So what is log 2 in base 2? It is 1. So we have 3 over 2 times 1 plus 1 over 2. What is log 3 in base 3? It's also 1. So 3 over 2 times 1 is 3 over 2 plus 1 over 2 times 1 is 1 over 2. We have addition of fractions here. Addition of fractions, which if we complete it, they say find LCM. We have alternative methods since the denominators are the same. But let's find your LCM. The LCM will be 2. When 2 divide this is 1, 1 times that will give us 3. You remember how you do your fraction, that's not why you're here. 2 divide this is 1 times that is also 1. So we have 4 over 2, which will give us 2. You know, when the denominators of fractions are the same and they are added, just add the numerator and divide by the common denominator. If I have done 3 plus 1, it will give me 4. If I divide by 2, I will have 2. But that's, you can only do that if the denominators are what? The same, or when they are the same. So the general principle is you find the LCM and do what I just did now. If you are finding it difficult to add fractions or to simplify fractions, you also watch our video on fractions. When you do that, you will become a baba in what? In fraction also. Okay. I think so far so good. We are going to just give you some questions. As we conclude this part, we're going to give you some questions that you are going to take away as your lunch. So let's have our lunch. Let's have our lunch. And let's have our lunch. Now, I believe you are taking note of all this. Let's have our lunch. Let's have our lunch now. So what's the lunch? What do we have for lunch today? Lunch questions. We have fried rice. Oh. Somebody's about to enjoy. Somebody's about to enjoy some food. Yeah, I know you will enjoy it. There's no doubt that you're going to enjoy the fried rice. So let's simplify the following. Simplify the following. Simplify the following. We have the first question that we want to treat here is log 32 base that. Okay. Log 8.1 base 3 plus log 10 base 3, that's 1, and that's 2 minus log 16 base 10 minus log 2 base 10 plus log 320 base what? Base 10. And then the third question, we have a beautiful man of log square root of 27 base 9 minus log 0.04 base 5. And then finally, our lunch, we have simplify log 25 in the 0.2 minus log 27 over 125 in base 0.6. Wow. And plus square root of 8 in this 2. Beautiful. Beautiful. Now, these are the questions that you need to take away with you. So we have our lunch questions. Very, very important that you solve them. If you solve them, you can put the answers you got on our comment box, maybe on the YouTube or on the Facebook page. We'll still look at the corrections of it so that you now check where you made mistakes and then correct yourself. So we'll still revisit these lunch questions, but this time around to solve them. This is where we will conclude the second case on simplification of what? Of terms and expressions involving logarithm. We have really done justice to this. If you are still finding it difficult, we need your feedback. We need your feedback. Always give us feedback. The feedback is necessary to enable us improve on the quality of this video, and also if there are things, some issues that you may want us to address, some areas that are still not clear to you, just do well to contact us. Our email is always available on our Facebook page, and also our contact is there, so you can actually contact us at any point in time when you are finding it difficult. Now, if you have need to meet us one-on-one, you can still contact us. If you still have needs on other science subjects like physics, chemistry, biology, you still want a very good tutor that can handle your child or that can handle you as a student, then do well to contact us. We are here to serve you and to give you a better service. God bless you as you keep watching Mathematics Meal. Do not forget that a meal a day is capable of taking away mathematical stupidity. God bless you. Thank you.